This is the solution to the Spring 2018 problem number 18. We have a mass being pulled by another mass by means of a pulley. The other mass is dangling over the edge of the table. We're given a static coefficient of friction, and we're asked what is the mass at which this static friction will be broken. So as this becomes more massive, it's going to exert more force. And until it's massive enough, the friction will be enough to hold this in static place. But if this gets large enough, then it'll start moving. So that's what we're being asked to solve. If we draw the free body diagram for M1, we have the tension pulling this way. We have the friction, which is oppositional, it's static friction. And we have the normal force pushing up against the weight, and we know that N equals M1G, and that's going to help us when we have to calculate the friction. For this mass, we have M2 with the tension pushing up and M2G pulling down, and we're defining this as the positive direction. So if we write the equation, we have M2G going in the positive direction minus T going in the negative direction. In both of these cases, the acceleration is 0 since it's the static case. So I write T minus F sub s equals 0, and then I write M2G minus T equals 0. And so we know that the tension is going to be M2G. So because this is a static problem, the tension on this rope is just equal to the weight of this block. I will remind you guys that if this was not a static problem, if it was accelerating, then the tension would not be equal to just the weight of M2G. But because it's a static problem, that is the case, because this is 0. And so we can substitute this into this equation. So we get M2G for the tension minus F sub s equals 0. And we know that F sub s is mu s times M1G, which is the normal force. And so this is our equation. The g's cancel, which is nice. And we end up getting that M2 equals mu s M1. And so when we plug that in, mu s times M1 is 2 kilograms, which equals 0.5 kilograms. So at 0.5 kilograms, this is exactly at the threshold where the force exerted on M1 is exactly equal to the static friction, the maximum static friction. If this were less than 0.5 kilograms, then the force on this would be less than the maximum static friction, and then the static friction would be whatever it needs to be to hold this in place. So 0.5 is the threshold. Anything larger than 0.5 kilograms and this problem is going to move. Anything less than 0.5 kilograms and it stays static. And that's the solution.